So yeah, this is the one gateway API to rule them all, and in the darkness, in the cluster configure them. I am Flynn. I'm a tech evangelist for Linkerd at Buoyant. You can find me on basically all of the Slacks that have anything to do with the CNCF as Flynn. If email is your thing, you can send email to flynn@buoyant.io. That works as well. The point here is that it would be really nice to have one way to talk about all the different kinds of traffic that can happen in Kubernetes, whether that's traffic from outside the cluster going inside, Ingress traffic, or traffic between workloads in the cluster, or traffic leaving the cluster for outside. It would be nice to be able to talk about these things in pretty much the same way. So we're going to talk a little bit about these kinds of traffic, and then if the demo goddesses smile upon us, we will have a demo. Now is an appropriate time to start praying to the demo goddesses. It worked great in rehearsal, but all right, so we are going to start with Ingress. Specifically, this is the Ingress problem, not the Ingress resource or Ingress controller. So this is the Ingress problem. The problem is pretty simple. If you have a cluster and you have workloads in the cluster, you will have users outside the cluster who want to use things inside the cluster. But one does not simply send packets into a cluster. Clusters do not let you do this. This is a critical thing about security within Kubernetes. You can't just randomly talk to things inside a cluster. So instead, we need something to sit right there at the edge to mediate this path from outside to inside to do this safely. That thing, historically, is called an Ingress controller. I should also point out that, yes, there is a thing called an Ingress resource. We're not really going to talk about that. It's sort of back from the bad old days. So the egress problem is kind of the opposite of the ingress problem, where sometimes also you have workloads in your cluster that need to talk to things outside your cluster. And generally, one does simply send packets outside the cluster. This is allowed, for the most part. And in fact, that is the egress problem. Because, yeah, okay, for the most part, your workloads will be talking to things that they should be talking to. Maybe they're talking to your payment processor, or they're talking to your bank, or they're doing good things like that. If they decide to not do good things, we would like to be able to do something about that, right? Where doing something might mean several things. We might just want to monitor it, to report it, or we might want to take some sort of action. The simplest thing here really is just monitoring. You want to be able to see who inside the cluster is sending traffic to where outside the cluster. If you don't even know that workload 2 is sending traffic to evil.evildoers.com, it's very difficult to do anything about that. Beyond that, of course, you might want to take some sort of action, like blocking the unapproved traffic. But another interesting thing is you might also want to take the egress traffic and funnel it all through sort of the opposite of an ingress controller, funnel it all through an egress controller, where the egress controller gets the decision about what to allow and what not to allow delegated to it. This is the most flexible option. It's also the most complex option, particularly because purpose-built egress controllers are a little tough to come by. You can kind of abuse ingress controllers into being egress controllers sometimes, but there aren't a lot of options if you want something really built for the purpose. Ultimately, the ingress problem is about providing access, but the egress problem is about providing control. So we talk about them kind of as opposites or of two sides of the same coin. That's not quite accurate. They really do have different goals. So that brings us to Linkerd, and how does Linkerd fit into all this? I realize I really should have started with an apology. The abstract for this talk for a while was wrong because it said, oh, we've added egress to the Gateway API. We've actually added egress to Linkerd using the Gateway API. The abstract has been corrected, but if you want to get up and run from the room in protest because I got it wrong in the first place after writing 18 different abstracts in it was longer than 3 days, but it felt like 3 days. I will not be offended much. Linkerd is a service mesh. The purpose of a service mesh is to add security, reliability, and observability at the platform level under your application so that it can do it uniformly across your entire application, ideally without changing your application. So if you have traffic between these workloads, the point of Linkerd is to be able to go through and report on what's happening there, and to be able to affect the way traffic gets routed and do all sorts of cool things like retries and timeouts and all this amazing stuff. The way Linkerd does this is the same way that basically every service mesh does this. We take over the network. Including, if you have an Ingress controller, we will take over traffic from the Ingress controller, which puts the mesh in a perfect position to be able to measure your request rate, and measure your success rate, and measure latencies, and report on all that stuff, and also to take whatever action seems appropriate with any of this traffic. Linkerd, I should point out, does this with sidecars everywhere. Not all meshes do this with sidecars everywhere. We just like sidecars because they keep things simple. And if you have a sidecar that's really lightweight and fast, which, hey, we happen to, then it's OK to be running them all over the place. It's much more operationally simple that way. If Linkerd is already mediating and measuring all of this traffic, then that implies that Linkerd is also in a perfect position to be able to see all of your egress traffic and to measure that and to mediate that as well. And in fact, it is. Also, since Linkerd is meant to add security to your application, it really makes sense for it to be doing all of this stuff with egress, which raises a fun question of, OK, so why did we not always do this? And there are two answers. The obvious answer is because engineer bandwidth is hard to come by. A slightly less obvious answer, though, is that the technology is actually not really the hard part here. The hard part here is figuring out how to allow your users to talk about things, to tell you what they want in a way that actually makes sense for the users. Those of you who know me or have heard me talking at pretty much any of these over the last 6 years will recognize that this is a pretty common refrain for me. Sorry, 7 years. It's 2024. Yeah, I can do math, really. This finally brings us to Gateway API. Gateway API originally was designed to deal with the Ingress problem in a more graceful way than the old Ingress resource and things like that. So it was designed to be the thing that sits in between our users and our workloads, mediates everything coming in from the cluster, does everything safely, all this good stuff. The point of it really is that the core of Gateway API is independent of the infrastructure you run it on. So in much the same way that you can learn how to use a deployment and a Kubernetes service and things like that, and then if you switch from using, I don't know, K3D to running it on Google or Amazon or your favorite cloud provider of choice, you should not then have to relearn how deployments work. Same deal. Once you learn how to use Gateway API for Ingress, you really should not need to go and learn lots of stuff if you have to change the infrastructure underneath. That's the promise. Those of you who use Gateway API, we would welcome feedback on how well we are delivering on that promise. Gateway API works by defining a bunch of resources that you then use to configure all of these things in your system. So there's a gateway resource that you use to configure the thing right at the edge of the cluster. Gateway API purists in the room. Yes, I recognize that gateways do not have to be at the edge of the cluster doing Ingress, but that is how they are most often used. And we'll come back to that in a little bit. There are also a bunch of route resources like HTTP routes and gRPC routes and TCP routes and TLS routes, and I think there's a UDP route. These things configure how traffic is routed just between different points in the cluster. If you're looking at this for Ingress, then here's a sample simple HTTP route for Ingress that basically says any HTTP traffic that shows up at the gateway named Faces Gateway, if its host name is smiley.example.com, or more specifically, if the thing in the host header is smiley.example.com, please route that to the Kubernetes service named Smiley, use it port 80, and since I have not said anything about namespaces in that backend ref, that will be using, or in the parent ref, that requires a gateway in the Faces namespace, and it requires the service Smiley in the Faces namespace. This is a simple route. Come on, phone. There we go. Yeah, I got ahead of myself. Sorry about that. HTTP traffic arriving at this gateway with this host name, goes to this service, and this is the problem with using your phone as your keynote remote and then accidentally having it flip over to the camera. Not that that ever happens. We can get more complex about this, right? So we can do things like add a second backend ref, in which case traffic will be split across these two services, the service called Smiley and the service called Smiley2. We can add a matches thing so that we require a path as well as just the host name. We can do lots and lots of things with this. And most of these things we can also do for gRPC. Things get tailored a little bit differently. It doesn't make as much sense to do path matching for gRPC, so instead we match on the gRPC service and method, and it's a lot better. All right. The concepts that I was just talking about of routing around HTTP traffic or routing around gRPC traffic, there's no particular reason those should be limited to Ingress traffic. The same concepts work just as well if you're talking about traffic between the workloads in your cluster and you're using a service mesh to do routing. And in fact, the same resources even make sense because you're solving the same problem. Ultimately, the difference here is not what the request is or what it looks like. The difference is where the request arrives. So in the mesh, what you do is you use a parent ref of a service rather than a parent ref of a gateway. And this is saying any HTTP thing that shows up at the Kubernetes service named Smiley on port 80 should get routed over to the thing on Smiley on port 80. This is a very self-referential route, but this is okay. You can go ahead and get more complex with that. It's also worth pointing out here that the mesh may or may not support everything your Ingress controller does. I don't know of any service meshes that support cores, for example. I'm not actually sure what that would mean, which is probably why none of us do it. So we have these things called routes, which people tend to think of as defining the way routing happens, but it's interesting that they also end up defining classes of traffic. So if you are looking at this, the parent ref actually tells you what kind of traffic it is, and correspondingly, to deal with a particular kind of traffic, you have to use the right kind of parent ref. So if you are doing Ingress traffic, the parent ref must be a gateway. I said we would come back to this point about gateways are not always about Ingress. Gateways are always about crossing administrative domains, and so you are always talking about Ingress into a particular administrative domain of which the cluster is the most common. If you are doing mesh traffic, the parent ref must be a service. It cannot be a gateway. Okay, great. What about egress traffic? Presumably, we need to have a parent ref that makes sense for egress. We can't use a gateway because gateways are talking about rendezvous points within a cluster, and egress traffic, by definition, is leaving the cluster. We can't use a service for much the same reason. I mean, there is such a thing as an external name service, but you cannot possibly do an entire internet worth of external name services, so let's not try that. Really, we need something new, and the thing we came up with for Linkerd is called an egress network, which has a pretty specific definition. It's talking about a class of traffic that is leaving the mesh for a destination that matches a particular CIDR. That phrase, leaving the mesh, is particularly important here. If you're using Linkerd multi-cluster, traffic between your two clusters is not egress traffic because it's still within your mesh. Same thing applies if you're using Linkerd to do external workloads. Not egress traffic because you are staying within the same mesh. Egress networks themselves are pretty simple. This one just says, don't allow any egress traffic, which is probably not the way you start first, but it's a reasonable sort of thing to do. Note that the API group up there does not say gateway.networking.k8s.io. This is not a gateway API resource. This is a Linkerd resource. Whoops. Here's one that blocks traffic to a specific network. Bonus points to anyone who walks up to me afterwards and tells me what is wrong with this slide. Also note that the egress networks I've been showing you are in the namespace Linkerd egress. This is a special magic namespace You can change its name, but it's the default egress namespace. If you see egress traffic coming from a namespace that does not itself contain an egress network, Linkerd will look to the egress networks in Linkerd egress. Because otherwise it's really, really hard to do something like, hey, no egress traffic in this entire cluster is allowed, except for the exceptions that we do. Now, we get to use egress network as a parent ref so that we can talk about egress traffic. And in this case, why in the world did I circle the host name first? This is an HTTP route basically saying anything going to smiley.example.com that is also egress traffic is going to be allowed by this route. Egress networks define, actually I should phrase that differently. Pretty much everything in Linkerd works by you deny things and then you allow the traffic through that you want. We don't really do things like, oh, we have a global allow and then you have specific exceptions to deny. That ends up being really hard. So instead we do global denies and then you get to be explicit about what you allow. So this is saying that because the parent ref is all egress traffic, this is saying, yeah, block everything, because that's the last thing we said in the egress network. And then we're going to specifically allow HTTP traffic to smiley.example.com. Note that the parent ref has to specify a group now, because the default is gateway.network.indicates.io. Also notice that we are specifying a port. Routes with parent refs of egress networks must specify the port, because you generally do not want to do things like HTTP traffic on any port that happens to mention a particular host name is OK. That's kind of silly. And you can do much more complex things with this, right? Matches work, and we'll get to some of the other stuff in a bit. You can do a backend ref in particular to funnel all of this stuff into an egress controller. If you don't have a backend ref, then the traffic just flows out as normal. If you do have a backend ref, it gets taken there so that the egress controller can decide what to do with it. You might want to be careful to allow your egress controller to speak outwards, or bad things happen. Not that I know that from personal experience. All of the route types work here. So you can do this with HTTP route or gRPC route or TCP route and TLS route, actually, although we're not going to show that today. That brings us to a brief discussion of what the demo is going to look like before we see if the demo works. I mean, before we look at the demo, because of course it'll work, right? The demo architecture, we have an application called Faces. That's what it often looks like. We will see it looking better than that. But Faces was mostly designed to allow you to experiment with reliability mechanisms with a really terrible application. Faces was also designed to show off just how badly things can go wrong, even in a very simple microservices application. We start with the cluster. We have a web browser running the GUI. Each of those cells in the GUI is making a call to the face workload. The face workload in the cluster calls the smiley workload, and calls the color workload. Smiley is supposed to return that grinning smiley face. Color is supposed to return the color blue. The face workload puts the two of them together so that the GUI knows what to show. It is a very simple application, and it is absolutely remarkable how many different failure modes it has. We have some other things running in the cluster as well. And evidently, we have a duplicate slide here. Wow. Don't try this at home, kids. It's always fun seeing where your demos or seeing where your slide decks end up with things that are not supposed to be there. Okay, that's supposed to be there, because we are in fact running, we're going to be using Envoy Gateway as the gateway controller providing Ingress access, and then we've got Linkerd for the mesh everywhere. And so that is correct. And yeah, that was kind of fascinating. All right. Let's see what happens. I've actually already set up my cluster here with all of the relevant things running in it. So we have the Envoy gateway system here, we've got Linkerd, and we can make sure that Linkerd is running okay. This is not installing Linkerd right now. This is just running the check to make sure that everything is okay. Please ignore all of the proxies not running the current version. I'm running a version from a whopping like 2 weeks ago, maybe, but we've done 2 releases since then, so yeah. We can also see that we have a gateway set up for Envoy Gateway, which is great. We're running on K3D, so I'm just going to use localhost to go and talk to this. And if I do that, I get nothing, which would be alarming except for the fact that I haven't created any HTTP routes yet. So this is the HTTP route I'm actually using for the call going to face. I'm not going to show you the one for the GUI because it looks exactly the same with face changed to GUI in some strategic places. This is saying anything that arrives at the gateway whose name is Ingress, if it matches /face at the beginning of the path, rewrite that chunk of path to a /, and then send it to the face service on port 80. And then there's a basically identical one that says, when you see a path starting with GUI, go to the face's GUI workload. So if we do that, and we apply the face route as well, and I come over here and reload this window, I have a running application. Well and good. Okay. Now, we're going to go through and skip mesh routing for a little bit and skip straight to egress. I've actually cheated a little bit in the way I talked about the demo architecture. If we look at the pods, if you look carefully, you'll see that there is a face pod, and there is only color 2 and color 3 and smiley 2 and smiley 3. Because the way I've actually set this up, smiley and color are not running in this cluster at all. This is all running in a K3D cluster. Smiley and color are running in separate Docker containers on the same Docker network. So all of the traffic from the face workload to smiley and color is egress traffic. And if we look at this right now, and we try to get Linkerd's proxy metrics, there is nothing. The reason for this, the reason that there is nothing, is that we don't have any egress networks defined. We have not told Linkerd to start paying attention to this kind of traffic yet. So we can fix that. This is creating our Linkerd egress namespace, which I mentioned before. This one creates an egress network called all egress, explicitly setting the traffic policy to allow, so that the only thing we're going to do here is monitor. We're not going to actually stop anything. If I apply that, nothing happens with my application. I didn't wait long enough before doing that. You remember when I was talking about praying to the demo gods? I don't know, might be bad. Okay, better, at least slightly better. All right, we've got some metrics there going on there. Let's switch that to denying everything instead. All right. Y'all didn't pray hard enough to demo goddesses. Let's figure out how I broke everything here, shall we? We do have the right things doing that? Yes, we do have the right things doing that. That's good. You know, I am not going to lie. I have never had this demo fail in this way before right now. That's awesome for some value of awesome that isn't very awesome. All right, let's check one other thing here. Nope, Linkerd is running. Faces is meshed. I think I know what's going on here. Okay. Pay no attention to the man behind the man on stage switching to a newer version of Linkerd. Wow. Okay. All right, so this will be kind of fun, both in the sense that nobody is supposed to actually see this part from stage, but also because I'm slightly trusting the network to do good things here. There was a point where Linkerd's edge releases supported the stuff that I'm trying to show, but they did not support the global egress default namespace. Earlier today, in fact, just a couple of hours ago, I did a demo, I did a workshop rather, on configuring meshes with Gateway API, and some of you may have been there. That demo, I believe, downloaded the older version of Linkerd and switched to it. And this demo is not written to be paranoid about switching to the right version of Linkerd. So I think that's what's going on here. And yeah, this is going to be fun, or something like that. Okay, there's Linkerd being installed. Here's Linkerd actually getting running. Whoops. While that is running, since we are kind of slightly off the reservation here, one of the things that's really fun about doing this with, normally when I do this at KubeCon, I've carefully gone through and made sure that all the images I need are loaded into K3D so I don't have to go download the images on conference Wi-Fi. And okay, so far so good. It's pulling some images and it's actually working. And in the process, you're also getting a demo of how quickly you can install Linkerd and completely blow away a cluster and restart it. This was not on the agenda, but hey, why not? Let's do it. You know? Okay, that worked. Good. I feel much better about that. All right. Now, I'm going to skip a bunch of things here because we've already done them. But we really do need these routes. Okay. Oh man, I should ask somebody to time that. All right, let's do that. Let's wait a couple of seconds here. All right. Whew, I feel much better now. So yeah, the first time we ran this, before we had an egress at all, we saw no metrics at all. And we come back here and we can see some really painful to read things that demonstrate that, oh, hey, look, an egress network is involved. Oh, hey, look, this is the name of the egress network that's involved, and things like that. So this is really terrible to read. Instead, I shall run my horrible Python program down here that is parsing this stuff and just showing some metrics. If you were doing this for real, you would do this with Prometheus and Grafana and actual tools for monitoring. I'm frankly showing off here by demonstrating that you can actually do this in a command line format using a Python script if you're sufficiently masochistic. I mean, clever. All right. Now we're going to switch this to deny. Everybody cross your fingers again. That's what we're supposed to see. OK. So at this point, the GUI can talk to the face workload. Face is trying to talk to Smiley and color, but that is egress traffic, and we have just explicitly told it not to allow that. So it's not going to allow that. Face talks to Smiley using HTTP. I'm going to rush a little bit on some of this because we're actually running out of time from recovering from the things not working. If I go through and do that, then I have told it, hey, egress traffic with a hostname of Smiley is OK. I can do the same thing with gRPC just for variant, just for variety. Instead of doing a hostname thing, I'm doing here saying any gRPC that has the service of color service should be allowed. That is happy. That's good. Let's see what else here. There's a lot of stuff we could do that I'm not really going to go down the rabbit hole on, but one of them is, for example, we can put in this path match, right? And in the gRPC world, we can add the method match. And if I do this, these cells in the center show up with a path of /center and are using the gRPC method center. And these ones around the edge say edge. So if I apply this one, then the edges should be OK, and we should get gray cursing faces in the center, because that traffic is no longer allowed. So now, another entertaining thing we can do here is we can go through and force all of that stuff through an egress controller. I'm going to abuse Envoy Gateway. Again, it's an egress controller. I'm going to abuse it and make it an egress controller. This is also set up already. Notice that the address there is different. This service is not a load balancer service. It's just a cluster IP. There's no way to reach this Envoy Gateway from outside the cluster because we don't want it to be an Ingress controller. So if we force the center cells through that by adding back in, actually this is a new route, sorry. Creating a new route, still an egress parent. Now we've got a center path prefix, and we're going to force it through our Envoy Gateway as an egress controller. If I do that, then nothing happens. Oh, I'm sorry, I forgot to go through and show the gRPC version of that, which was in the same file. I promise you it's there. This doesn't work because I didn't create any egress routes for my egress controller. So it's getting to Envoy Gateway, and Envoy Gateway is coming through and saying 404 on some of those, and permission denied on some of those, because we're routing it into the egress controller and it's failing. So, oh yeah, I also do have to confess that Smiley2 and Color2 are running in my cluster. I'm just kind of pretending they're outside. You can use Envoy Gateway to route to things outside the cluster. It takes a little extra work, and I didn't want to do it. But this is an Envoy Gateway route that's basically saying, OK, so anything going to the Smiley hostname, if it shows up at my egress gateway, not my egress network, then anything with the right path, just send it over to Smiley2. Same thing with Color2 on the gRPC side. And if I apply that, then we get hard-eyed smileys on green backgrounds in the center by routing them through an egress controller. I'm going to do one more thing really quickly and then go over to some gotchas and then questions, which is I also have a thing in here called face2. And face2 bypasses Smiley and Color entirely and goes straight to Smiley3 and Color3. So when I do this, none of my traffic will be egress, and everything we've just done should be completely irrelevant. So when I do this, I've just said anything going to my face service, which is the request coming from the GUI in the first place, route them directly over to face2 using Linkerd, because mesh routing is the only piece of my original diagram I haven't shown yet. And if I do that, then we get rolling-eyed faces on blue backgrounds. And if you watch in this lower window, you're going to see all my egress metrics fall to 0 because there is no more egress happening. It's actually going to take a little bit for it to update. But this is showing. We used HTTP routes to configure the ingress routes from our Ingress Envoy gateway into the Faces application. We used Gateway API to configure egress policy, also using Linkerde's egress network resource. And this last bit is we used Gateway API to configure routing within Linkerd entirely, ignoring the whole egress thing entirely. So we actually have been able to use one Gateway API to do the entire thing that we wanted to do in the beginning. There, we finally got back to 0. And on that note, one API, gotchas. Right, let's talk about gotchas. I keep deleting that slide, it keeps coming back. If you don't list a CIDR for an egress network, it defaults to everything except the cluster networks that you provided as a parameter when you set up Linkerd. If you don't set up that parameter, it defaults to all the RFC 1918 networks. The point of cluster networks is to tell Linkerd, these are the networks that are a part of the cluster and everything else is not. Since cluster networks defaults to the union of all the RFC 1918 addresses, if you are trying to use IPv4 egress, you are almost certainly going to have to override that when you set up Linkerd in the first place. We recommend that you make cluster networks the union of the pod CIDR, node CIDR, and service CIDR for all of your clusters in your multi-cluster setup. I mean, if you're using multi-cluster, otherwise it's just your one cluster. Any route that has an egress network as a parent ref must specify a port. The port is optional in Gateway API, but it is not optional for this application. Because again, you really are not trying to say HTTP on any port is okay. Also, I mentioned the global default egress namespace. Any egress in your local namespace will completely override the global stuff. It is not an overlay, it's not a composite, it just replaces it. It's much easier to reason about that way, but it's occasionally a gotcha. Also, TCP route and TLS route are required by Gateway API to have at least one backend ref, because for Ingress and for service mesh, we can kind of make some reasonable assumptions about defaults. That just doesn't hold for TCP route and TLS route. So in Linkerd, you can use the egress network as the parent ref, or sorry, as the backend ref. And you will likely want to do that for an egress route. If you do, it has to be the same egress network that's the parent ref. Just FYI. And that is it. The QR code on the left is an easy way to get to Buoyant Enterprise for Linkerd, which we really hope you'll check out because it's awesome and great and does good things and permits people like me to still have jobs. The one on the right is the Gateway API end user survey. If you are using Gateway API, we would love to hear from you about that. And while I don't really want to keep you here any later than anybody wants to be, if you have questions, I can stick around. Thank you very much. I appreciate it. It's always fun when the demo goddesses do not, in fact, smile upon us.